In this video, we are going to solve question number 3 of exercise 1.2. So the question is, find the LCM and HCF of the following integers by applying the prime factorization method. So remember, here we have to apply only prime factorization method in order to find out the lowest common multiple and highest common factor of the following integers. So the first subpart here is 12, 15 and 21. Let's prime factorize. For 12, we are going to get 2 6s are 12. Now 2 3s are 6. For 3, we will divide it with 3 only. So we are going to get 1. So we can write down 12 as 2 into 2 into 3, which can be written further as 2 raised to 2 into 3 raised to 1. Now since 15 is an odd number, we will be dividing 15 not with 2. We'll start division of 15 with 3. So we are going to get 5 as a quotient. Now 5 is a prime factor, so we will be dividing 5 with 5 in order to get 1. Let's write down 15 as the product of the prime factors. 15 will be equals to 3 into 5, which can be written as 3 raised to 1 into 5 raised to 1. Now let's do the prime factorization of 21. We are going to get 21 when divided with 3 will give you 7 as a quotient, and 7 is a prime factor, so we will divide it with 7. We are going to get 1 as a quotient. Therefore, we will be writing 21 as 21 equals to 3 into 7, which can be written as 3 raised to 1 into 7 raised to 1. For highest common factor, we will be writing down the least exponent possible for that prime factor. So here observe, in 12, 15 and 21, the least exponent of 2 is 0. It is not occurring in 15 or 21. So therefore, we will be writing 2 raised to 0 here. 3 is occurring once in all the 3 numbers, 12, 15 and 21. We can observe 3 raised to 1 here, 3 raised to 1 here, 3 raised to 1. So we will be writing 3 raised to 1. Now, since 5 is not coming as a prime factor in 12 and 21, we will be writing 5 raised to 0. And also 7 is not coming as a prime factor in 12 and 21, so we will be writing 7 raised to 0. The least exponent possible is 0. Now, if we will multiply all these numbers, we are going to get 3 as its value. Since 2 raised to 0, 5 raised to 0 and 7 raised to 0, their value will be 1. So, on multiplying 1 with 3 raised to 1, we are going to get 3. Now, let's find out the LCM, lowest common multiple of 12, 15 and 21 using prime factorization method only. 12, 15 and 21. First of all, we will divide it with 2. So, we are going to get 6 over here, here 15 and here 21. Now again, we can divide it with 2. We are going to get 3 over here, here 15 and here 21. Now, we can divide these all 3 numbers with 3. We are going to get 1 here, 5 here and 7 here. Now, we will try to divide all these 3 numbers with 5. So, here we are going to get only 1. Here, we are going to get 1 as a quotient, and for 7, we will keep it as it is. If you will divide 7 with 7, we are going to get finally, for all the 3 numbers, we are going to get the quotient as 1 only. So, this is the way we can do the prime factorization and find out the LCM, lowest common multiple of 3 numbers. We will be writing lowest common multiple is equals to, LCM is equals to 2 raised to 2 into 3 raised to 1 into 5 raised to 1 into 7 raised to 1. So you can observe 2 is occurring twice, 3 is occurring once, 5 is occurring once, 7 is occurring once. So the product of all these numbers will give you 420. Now this is the second subpart of question 3. Let's try dividing 17 first of all. 17 is a prime factor, so we will get 1 as a quotient on dividing 17 with 17. Again, for 23, since it is a prime number, so we will divide 23 with 23 in order to get 1 as a quotient. Again, let's divide 29. Let's prime factorize 29. So we are going to get on division of 29 with 29, since it is a prime number, we are going to get 1 as a quotient. So therefore we can write down 17 equals to 1 into 17, and hence it can be written as 17 raised to 1. 23 can be written as 1 into 23, which will be written as 23 raised to 1. And 29 can be written as 1 into 29, which can be written as 29 raised to 1. So the highest common factor possible would be 17 raised to 0 into 23 raised to 0 into 29 raised to 0, which will be equals to 1. Now for lowest common multiple, let's use prime factorization method. So what we are going to do, we will be writing 17, 23 and 29 and try dividing it with, first of all, 17. So here we are going to get 1, here 23, here 29. Now again, if we will divide it with 23, we are going to get 1 here and 29 over here. Finally, we will be dividing it with 29. So on dividing it with 29, we are going to get 1, 1 and 1 over here as well. So finally, we will be writing LCM, lowest common multiple, as LCM is equals to 17 raised to 1 into 23 raised to 1 into 29 raised to 1. The product of all these three numbers, 17, 23 and 29, will give us 11,339. Now this is the third sub part of question 3. Here we have to find out LCM and HCF by using prime factorization method. So first of all, we will prime factorize 8. If you will divide 8 with 2, we are going to get 4 as a quotient. And on dividing 4 with 2, we are going to get 2 as a quotient. Again, on dividing 2 with 2, we are going to get 1 as a quotient. Now, for 9, since it is an odd number and it is divisible by 3, we can divide 9 with 3. We are going to get 3 as a quotient. And on dividing 3 with 3, we are going to get 1 here. Now, for 25, we can divide it with 5. Since the unit place of this 25 is 5, so it is divisible by 5. We are going to get 5 as a quotient. Again, 5 is a prime factor, so we will divide it with 5 in order to get 1 as a quotient. Therefore, we will be writing 8 is equals to 2 into 2 into 2, 2 raised to 3. 9 is equals to 3 into 3, 3 raised to 2. And 25 is equals to 5 into 5, 5 raised to 2. So finally, the highest common factor of all these three numbers will be equal to 2 raised to 0 into 3 raised to 0 into 5 raised to 0, which is equals to 1. Here we could observe that the least exponent possible for 2, 3 and 5 is 0. Therefore, we are writing 2 raised to 0 into 3 raised to 0 into 5 raised to 0, which is equals to 1. Now let's find out the lowest common multiple using prime factorization method. So we will be dividing 8, 9 and 25. So if we will try dividing it with 2, we are going to get 4, over here 9 and over here 25. Again, on division with 2, we will get 2 here, 9 here and 25 here. Again, on dividing it with 2, we are going to get 1 here, 9 here and 25. Now, we will be dividing it with 3. So, we are going to get 1 here, 3 here and 25 here. Again, on division with 3, we are going to get 1 here and 25 here. If we will divide it with 5, we are going to get 1 here and 5 here. Finally, on dividing it with 5 will give us 1, 1 and 1 over here. So, we will be writing down the LCM as LCM is equals to 2 raised to 3 into 3 raised to 2 into 5 raised to 2. Observe, 2 is occurring thrice, 3 is occurring twice and 5 is also occurring twice. So, therefore, we are writing 2 raised to 3 into 3 raised to 2 into 5 raised to 2, which will be giving us 1800.